All right, calculus class, here we go. We are going to do a video here that is going to guarantee to help you get ready for quiz coming up over domain, zeros, and the difference quotient. So here we go. What I'm going to do is I want you to get out some paper right now, get out a pen, get out a pencil, get out your calculator, be ready to do some work here. I'm going to put up a problem, and the first set of problems we're going to do is finding the domain. And your goal is to pause the video after I put the problem up and then come back to the problem, and then you could see how I did. If you're still a little bit confused, then don't hit pause and just kind of watch me work through the problem here, and hopefully you understand. So the first problem that we're going to find the domain of is the function, the square root of 3x minus 21. So if you need to, go ahead and hit pause and try to find the domain on your own, and then come back. So I'll give you a second to hit pause. All right. Now back to the problem here. The first thing I have to think of is with square roots, the number inside the square roots, the 3x minus 21 has to be greater than or equal to 0. So I'm going to add the 21 over, and I'm going to divide by 3, and I get that x is greater than or equal to 7. So the domain would be any value starting at 7, bracket because I'm allowed to equal 7. 7 would make a 0, and zeros are not a problem with square roots, all the way on towards infinity, towards forever. So that's the first problem. All right, here comes the second problem. Here's the function, and again, our goal is the same thing, to find the zeros. It is the square root of x plus 3, and here's a little bit of a trick. It's divided by x minus 4. All right, so go ahead if you want, hit pause, try to figure it out. This is a doozy. It's a good one. Come back and see if you got it right. All right, here we're back to the problem here, and one of the key issues is the x plus 3. And I know that inside of a square root, I must be greater than or equal to 0. I'm allowed to be 0 because the top of a function is certainly allowed to be 0. That's not a problem. So I'm going to go ahead and solve this by subtracting 3, and I know that x is greater than or equal to negative 3. So on a number line, here's negative 3. X has to be any number greater than that. But there's another issue. The bottom is an issue because I know the bottom is not allowed to equal 0, but x equaling 4 would be that problem. So 4 is a bad number to be, and because 4 would make a 0 on the bottom. Now, 4 would work on top. 4 plus 3 is 7. 7 is okay in a square root, but it's the bottom that causes an issue. So kind of a double whammy problem here. So x is allowed to be, according to the numerator, anything greater than negative 3, which includes 4, unfortunately. So every number other than 4 needs to be included in my answer. So starting at negative 3, every number afterwards except for 4. So here's how I give that as the domain and interval notation. Start at negative 3 with the bracket because I'm allowed to equal 3. I'm going to continue on until I get to 4, but remember I have to jump over top of 4, and that's why I use the parentheses. The parentheses tell me don't include 4, simply just skip it. So every number from negative 3 to 4 works, and then every number after 4 works. So that is the correct way to give the domain for this problem. So that was a good one. All right, let me give you another one here. The function is 2x squared minus 3x. So go ahead and hit pause if you want to try to figure out the domain on your own, and then hit play whenever you're ready to check your answer. All right, back to the problem. Here we go. This is an easy one. No square roots, no denominators. This one should take you about all of 10 seconds to figure out, negative infinity to infinity. So don't think that every single problem that you're going to come across is one of the really tough ones. All right, last domain problem for this video for you to practice with. The function is 5 divided by x squared minus 6x minus 16. So don't see any square roots, so don't have to worry about being greater than 0 or any of that junk. But I do see a denominator, and any number that makes that denominator 0 is an issue. So I have to first think to myself, x squared minus 6x minus 16. What number is going to make that equal to 0? Don't have to worry about the numerator because it's a 5. That's fine. The numerator doesn't matter when talking about domain. So let me see here. I got to solve this. And the way to solve a quadratic like this is, you could use the quadratic formula to figure out the values that make it 0. But I'm going to go ahead and actually factor because hopefully you guys are getting good at factoring. So how do you split apart an x squared? That's pretty easy. X times x. How do you split apart a 16? Well, one option is I'm going to just write down here to see if I'm on the right track, is an 8 and a 2. Can an 8 times a 2 make negative 16? Absolutely. Could they add to make a negative 6? Yeah, they could, because 8 minus 2 is 6. But actually, I need the 8 to be negative and the 2 to be positive. That way, when I take the 2x and the negative 8x, they add to make negative 6. And of course, they multiply to make negative 16. Now, why does this help me? Because now I found the factors, and they're linear factors. And linear factors are very easy to solve. X minus 8 equals 0. Add the 8, so I get x equals 8 is a 0. 8 minus 8 makes 0. That's a 0. That's going to cause my denominator to be 0, which is bad. So actually, I can't equal 8. X plus 2 equals 0. Subtract 2. Subtract 2. I get x equals negative 2. Negative 2 plus 2 is 0. But once again, that makes a 0 in the denominator, so I cannot equal that. So every number works except for these two numbers. So think of a number line. Negative 2, I have to skip over. 8, I have to skip over. But all these numbers here, here, and here, they all work. So how do I express that as a domain? Well, start at negative infinity, because every number below negative infinity works up until negative 2. Don't include it. Then every number in between negative 2 and 8 works, but no brackets, because I can't be negative 2 or 8. And then once again, every number after 8 works as well. So this says start at negative infinity, end at infinity, but in between you need to skip negative 2, you need to skip 8. So that's your answer. All right, next set of problems, a little bit different. Now we're trying to solve and find the zeros. We're trying to find the numbers that make the function 0. So here's the first problem, and it's a good one. It's a tough one, so I'm giving you guys this little helper here. 3x cubed minus 9x squared minus 30x. Okay, so if you want to try to figure it out on your own, go ahead and hit pause right now and then come back. All right, we're back. Here's the problem. Now, I want to figure out what makes the function 0, so I'm going to turn the function into 0. Now, you cannot solve under traditional methods of adding the 30x over and dividing or doing any of that kind of junk, because I got an x cubed, I got an x squared, and I got a 30x. So what I need to do is factor. And the first factoring technique I'm going to realize is if you look at all of these terms, every one of them has an x. This one has 1x, this one has 2, this one has 3, but they at least have 1x, so I can take an x out. Also, all of them involve a factor of 3. 3 times 1 is 3, 3 times 3 is 9, 3 times 10 is 30. So I could take out a factor of 3. So what's that leave me behind? It leaves me behind an x squared, because 3x times x squared makes 3x cubed. That leaves me a 3x left over, a negative 3x, because that would make a negative 9x squared. And that leaves me behind a negative 10, because the 3x and the negative 10 make negative 30x. So now this makes the problem a little bit easier. I got a 3x here, and what's left over I could easily factor. And you just leave the 3x in front for right now. So I got an x times an x to make the x squared. I got my negative 10. What makes negative 10? I'm thinking 5, and I'm thinking 2. But can a 5 and a 2 make a negative 3? You bet it. Negative 5 and a positive 2 add up to make negative 3. They multiply to make that negative 10. So 3x right here could be 0. That's linear. That's so easy to solve. Divide by 3. Oh, 0 divided by 3 is 0. So there's one answer. X minus 5 could be 0. Add the 5 to the other side. X equals 5. There's another answer. And x plus 2 could be 0. Subtract the 2. X equals negative 2. There's another answer. So I got 3 values all that make my function 0. All right, let's do another one here. Another problem where your goal is to find zeros. F of x equals 9x squared minus 25, all divided by 4x plus 2. All right, here we go. If you want to go ahead and try to figure it out on your own, hit pause and come back. All right, we're back. How to make a function 0. Set that equal to 0. Now remember, denominators, if they're 0, make me undefined. They make an error. So I don't really care about that denominator. So I'm just going to focus on the numerator, 9x squared minus 25. How do I solve this? Well, let's see here. This could actually be factored. This is what we call difference of squares. It's one of the review videos, by the way. 9x squared would be a 3x and a 3x, making the 9x squared. 5 times 5 is a perfect square. That makes 25. But one's got to be a minus and one's got to be a plus. That way, the 15x on the outside and the negative 15x on the inside cancel and make no x's in the middle. So I get 3x minus 5 and 3x plus 5. Let me show you one other way you could have done this. You could have added 25 to the other side and then divided by 9. And you get 25 ninths equals x squared. Take the square root, take the square root, don't forget the plus or minus. And the square root of 25 is 5. The square root of 9 is 3, so you get plus or minus 5/3. Now, where does that come up here? Wait and watch. 3x minus 5 equals 0. Add 5. I get 3x equals 5. Divide by 3, I get x equals 5/3. So there's the positive 5/3. And look at this one. 3x plus 5 equals 0. Subtract the 5. I get negative 5. Divide by the 3. I get the negative 5/3. So you could do this one by factoring or by solving it in this method right here. Either way, you get a positive and a negative 5/3. Awesome. All right, one more problem where you got to find the 0. F of x equals the square root of x squared minus 9x plus 20. All right, finding the zeros. If you want to pause it and try to do it on your own, go right ahead right now. All right, we're back. Set it equal to 0. That's how you find zeros. Now, again, don't try to start solving this because you're done trying to do greater than. This is not a domain problem. Don't confuse it. This is a 0 problem. So how do I solve this? Well, I don't like that square root right there. How do I get rid of it? Square it, because squares and square roots cancel. So I'm going to square this entire thing. That's going to cause the square and the square root to cancel. But I got to square this side too. That's easy. 0 squared is 0. So I get 0 equals x squared minus 9x plus 20. And once again, I got to solve this by either the quadratic formula or factoring. You cannot solve this using any traditional methods. So x times x is the x squared. Let's see, 20 is 5 and 4. Can a 5 and a 4 make a 9? You better believe it. Negative 5 and negative 4 add up to make the negative 9, and they multiply to make a positive 20. So that means x minus 5 could be 0. Solve that real quick. I get one answer. X minus 4 could be 0. Solve that real quick, and I get the other answer. So there's my two zeros. Easy, easy, easy. All right, two problems left, and we're going to do the difference quotient. So remember, the difference quotient is f of x plus h, and I'm going to give you this, minus f of x, all divided by h. Now remember, when you're done with this problem, when you get that h on the bottom to cancel. So here's the first problem. We'll use that little mark I made by accident for the number 1. All right, first problem is the function is 3x squared minus 5x. So if you want to go ahead and hit pause and try to do this one on your own, that would be awesome. And we're back. All right, so first thing I got to do is I know the h on the bottom. Duh. I know the f of x in the back. It's right there. I have to figure out what is f of x plus h. So that's going to be 3 times, not x, x plus h squared, minus 5, not x, x plus h, because I'm replacing the x with x plus h. So I got to do a little bit of dirty work real quick. I just got to figure out what is x plus h squared, which is x plus h times x plus h. Please don't just say x squared plus h squared, because you actually get x squared, you get an xh on the outside, you get an xh on the inside, and then you get an h squared. And the xh and xh make a 2xh plus h squared. All right, so I get 3 times, I just figured out that that is x squared plus 2xh plus h squared, minus 5 times x plus h. Do a little bit of distribution. I get 3x squared plus 6xh plus 3h squared minus 5x minus 5h. Don't forget to distribute the negative 5. All right, so now I'm ready to go here. F of x plus h, I just spent 2 minutes solving it. It is 3x squared plus 6xh plus 3h squared minus 5x minus 5h. Then I have to subtract the function itself, f of x. So be careful, because when you subtract, you got to run a negative through because you're subtracting. So I get negative 3x squared, and then I get a positive 5x, because you're subtracting, so that negative turns the 3 into a negative and the 5 into a positive. all divided by h. Okay, now, what's going to cancel? Let's see. Negative 3x squared, positive 3x squared. Awesome. 5x, negative 5x, double awesome. All that's left over is 6xh plus 3h squared minus 5h, all divided by h. Now, the first thing I notice is that, whoa, wait a minute, that's not what I noticed. Let me scroll back up here. Is that all of them have an h. All of these three terms on top have an h. So I can take that h out. I get 6x. I get a 3h. Again, there was an h squared. There's only one of them can come out. And I get a minus 5. Again, all divided by h. So those h's finally cancel, and that's how you know you're done when that h on the bottom cancels. So I get 6x plus 3h minus 5. Final answer. That is my difference quotient. Very, very, very good. All right, so let's move on and let's do one more difference quotient and we are done. Remember, the difference quotient once again is f of x minus h. F of x plus h minus f of x, all divided by h. All right, here we go. A little bit of a trickier function this time, but actually in some ways it makes the problem a little bit easier as well. 3 divided by x plus 2. Okay, this is a tough one. If you want to try to do it on your own, we did do one like this in class. Go ahead and hit pause. All right, we're back to try to find the answer. All right, all we got to do first is figure out what f of x plus h is. And remember, that's so easy. That's going to be 3 divided by, all I got to do is turn this x into x plus h. And then the plus 2 just goes down there as well because you can't get rid of that plus 2. And this is why the problem might be a little bit easier than the previous one because I'm done. There's nothing more I can do to find f of x plus h. So here I go to try to solve the rest of the final problem. Start off with f of x plus h. That's 3 divided by x plus h plus 2 minus the original function. The original function was 3 over x plus 2. That wasn't too bad. So we got f of x plus h minus f of x, all divided by h. Now, I need this h down here to cancel. And I'm going to start with the top because it says subtract. So I'm going to get that top to subtract. Now, in order to subtract two functions, I need a common denominator. Easiest way to find a common denominator is take the two denominators you have, x plus h plus 2, times x plus 2. Don't multiply them out. Just leave it like that. I know it doesn't look very nice, but leave it like that. This guy right here, to make him look like my common denominator, he has the x plus h plus 2. He needs the x plus 2. So I will gladly put one down there, but that means I got to put one on top as well. So go ahead and distribute, and I get 3x plus 6. Again, I just distributed 3x times the 2, 3x plus 6. Back here, this guy has the x plus 2. What does he need to look like my common denominator? He needs the x plus h plus 2. And I'll gladly add one there, but I got to add one on top. Now, be careful. Be so careful because this is really a negative 3. That negative needs to go to that 3. So I get negative 3x, negative 3h, minus 6. Again, that negative 3 would cause me to distribute negative 3 to the x, negative 3 to the h, negative 3 to the 2 there. Now, all of this is divided by h, but I'm going to make this a little bit easier. Remember, dividing by a value is the same as multiplying by its reciprocal. So instead of putting a big divide by h here, I'm going to multiply by the reciprocal of h, which is 1 over h. So on top, what's going to happen here? 3x, negative 3x, cancel, awesome. Negative 6. Positive 6. They cancel. That's awesome. That's very good. Oh, you know what? I made a slight mistake. Sorry, guys. This was a negative 3x and a negative 3h. So it was actually this guy that canceled. And this term right here was my mistake. Should have been a negative 3h. So actually, that's the only thing that's left over. So the 3x and the negative 3x canceled. The 6 and the negative 6 canceled. So that negative 3x that came from right here was left over. So on top, I got a negative 3h. That negative 3h was left over. On the bottom, I got a kind of weird common denominator, but don't worry about it. Just that's part of the answer. Just leave it like that. Now, look what's going to happen here. Remember, we're timesing by the reciprocal, which is 1 over h. Awesome. Now the h is canceled because everything else was gone. So my final answer is all I got left on top is a negative 3, and all I got left on the bottom was x plus h plus 2 times x plus 2. Now, I know that was a little bit tricky, but boy, oh boy, that problem was not that bad when you sit back and think about it. So hopefully those problems helped you guys prepare for Friday's quiz, and I think they will. Hopefully they, worked for you.